So welcome everybody. This is going to be a presentation called Introduction to VMware Cloud on AWS. My name is Michael Armstrong. I'm one of the lead solution engineers inside the Cloud Platform Business Unit with the responsibility for working with customers around VMware Cloud and AWS. If you've got any questions as we're going through the slide deck, please ask them in the Q&A box, and myself and another colleague will be more than happy to answer them as we go through the session. So today we're gonna walk through what VMware Cloud on AWS is. We're going to cover off from an architectural perspective how it works, how it integrates with native AWS services. We're going to talk around some of the benefits and some of the use cases that we see customers traditionally adopting VMC for. We'll cover off some of the ways in which you can consume VMC, and then a little bit on how the pricing actually works. And then finally, we'll just summarize everything that we've talked about as part of this presentation. So what we tend to see when talking with customers is customers want a hybrid cloud strategy. We find that customers today, they have a clear strategy of where they want to go when it comes to on-prem and when it comes to private cloud and public cloud. And what we tend to see is that around 83% of workloads are actually virtualized today. And 60% of large organizations or large enterprises actually run VMs inside public cloud already. So it's a natural fit. And 65% of organizations currently have a hybrid cloud strategy. So they have workloads that will reside on-prem, they have workloads that will reside in public cloud, and they might have a requirement in order to move workloads freely between the two environments. So for many, a hybrid approach is actually the preferred operating model. With the on-premises environment, you're used to the familiar tools and processes that you already run. You leverage your existing investments. You maintain unique hardware configurations and maintain granular control over the placement of applications and data. And with public cloud or with a public cloud environment, you want to be able to scale faster. You want to do things like reduce costs, perhaps establish a global footprint, and also have the option to pay as you go and access a broader range of services that are provided by that public cloud provider. So as customers move to the cloud, they look for ways to get the best out of both worlds without having to purchase any additional hardware. So there are several common challenges when it comes to hybrid cloud adoption. For example, you might have multiple virtual machine formats. You might have incongruent networks or even operational inconsistencies between your on-premise environment and your public cloud environment. Your team might have to learn new skill sets or utilize new tools, and you might even have multiple controls for monitoring your environments. You might have certain tooling for monitoring one environment and different tooling or scripts or processes for monitoring another environment. So we now have a common approach to a hybrid cloud environment based on common infrastructure combined with common operations across your cloud and your on-premise environment. This approach offers a consistent and a simple way to operate your infrastructure and your VMs, and also provides compatibility across your on-premise environment and your public cloud environment. If you're also looking at things like containers, you're already going to be ready for containers. The infrastructure is already in place. VMware Cloud Services with VMware Cloud Foundation will come into play between your private cloud and your public cloud. So this is truly a compelling and a complete differentiated solution. With VMware, you'll enjoy the leading compute, storage, and network virtualization capabilities. And additionally, there's support for a broad range of workloads and it's the standard for the enterprise data center. With AWS, you'll experience flexible consumption economics, the broadest set of cloud services and the global scale and reach of AWS. So VMware Cloud on AWS is comprised of VMware software plus AWS's global infrastructure. That means you'll have the VMware stack on AWS infrastructure, giving you VMware's compute, storage, networking, security, all delivered as a cloud service. Okay, so this is fully managed and maintained by VMware. VMware's capabilities in cloud infrastructure is sold as a combined offering. A unit of purchase is a physical host within VMware software, and the minimum purchase for a production software-defined data center, or SDDC, is 3 hosts. The good thing with this is you can add hosts in the increments of 1 if you so need to scale out that environment. So the key benefits of VMware Cloud on AWS is the seamless hybrid infrastructure from private and public cloud market leaders. So with VMware Cloud on AWS, you'll enjoy the rich VMware software-defined data center delivered as a cloud service on AWS's hardware. With this, you have the already consistent and familiarity of VMware technologies. So things like accessing vCenter and how you deploy and modify virtual machines is how you're currently familiar with as of today. We have easy workload and portability and hybrid cloud capabilities, so we can migrate workloads from on-premises into VMC. And as well as the direct access to the power of native AWS services and new and existing applications that AWS provide. Containers and native AWS instances can also be utilized as well. So the global reach of VMware Cloud on AWS is expanding over time. Today the service isn't available across different regions inside US East, US West, all across Europe and Asia Pacific as well. And hopefully, as you can see in the slides, we're looking to expand the service around the world as soon as possible. So hopefully every single AWS region that opens, we will have the capabilities of VMC inside there as well. So VMware Cloud and AWS, it offers support by third-party infrastructure partners. So currently, we have more than 100 solutions across different areas, such as backup, monitoring, analytics, security, DevOps, networking and storage, and these have all been validated on VMware Cloud on AWS. This list is growing. It's expanding on a daily basis, and you'll see additional partners get added to this list as the offering matures. So let's talk about what VMware Cloud on AWS actually is. Okay, so it's an on-demand VMware software-defined data center delivered as a cloud service. It includes the latest software, meaning the latest versions of vCenter, ESXi, NSX, and vSAN, which is all managed and supported by VMware. You also gain dynamic capacity, so including a DRS and HA compute cluster from Intel, vSAN storage cluster with NVMe flash-based storage, NSX networking virtualization, and these are all built on top of AWS's hardware infrastructure. So compute is provided to you with bare metal instances, and it's the i3.metal instance. This comprises of 36 cores, half a terabyte of RAM, and around 15 terabytes of NVMe or flash storage. We also have a 25 gig ENA or ENI that connects you into native AWS. With the hypervisor is obviously ESXi. You have the option to start with the minimum required, which is 3 hosts for a production cluster, and we can scale that out to 16 hosts per cluster. We support currently a maximum of 20 clusters per SDDC, which brings around 320 hosts per SDDC. As we mentioned, this is fully maintained by VMware, but there are some limitations. Okay, so things like you don't get access to SSH, or you don't get root access into the hypervisor or into things like vCenter. Because of that as well, you don't have the ability to deploy any of your own or third-party VIBs. Okay, so VIBs are VMware infrastructure bundles. You don't have the ability to deploy those into your environment. From a storage perspective, we utilize vSAN. So it's used to allow you to aggregate your all of the instances, all the host instances, into a single data store. We utilize all flash inside the i3.metal hosts, which provides the capacity and the caching tier inside your vSAN data store. You also have the ability to configure storage policies depending on the number of hosts and the number of failures you wish to tolerate inside the environment. From a networking standpoint, VMC utilizes NSX, and this provides our networking and security layer. We can create multiple logical networks. We also have full control over the north-south firewalling, which is used to protect your environment. We have what we call a computer management gateways, which we can allow or restrict traffic in and out of those gateways. We support IPsec termination. So a lot of customers will create IPsec VPN tunnels from on-prem into VMC to allow for connectivity to manage workloads or to manage the environment from on-prem. And we can also support NAT if you wish to allow external access into certain workloads inside the environment. vSphere is VMware managed, so it's allowing you to delegate permissions. So vCenter is used for this purpose, and it enables things like hybrid linked mode, so we can have a single pane of glass view of not only your on-premises environment, but also the resources that are currently running inside VMC as well. So you have a software-defined data center. It's comprised of things like vCenter, vSphere, ESXi is the hypervisor, NSX is the networking security layer, and vSAN is the storage layer. With that, we get to combine that with the native AWS services. So services such as EC2 for compute workloads, potentially S3 for storage, or RDS for database services. And because we connect via that ENI, that network adapter that connects our environment into native AWS services, we get to utilize the high bandwidth, low latency link and direct link into those native AWS services. All of this utilizes AWS's global infrastructure, meaning that your workloads reside in AWS. In VMC can fully utilize AWS's services. And we utilize the underlying backbone network for that as well. And if you were to have that on premise, data center utilizing a vSphere platform environment, you do not have the option to utilize. You do have the option to utilize connectivity with your VMware Cloud and AWS SDDC, and you can utilize those AWS services which are available to you as well. So, for example, you might have a vCenter on-prem, which can then be linked through hybrid links modes through to your vCenter server that exists within VMware Cloud and AWS. But if you want to have native AWS services being utilized by your VMs, you've also got that option as well. Okay, so you have your workloads on-prem, you have your workloads inside VMC, and you might want to take advantage of some of the native AWS services. And once again, that's all communicated back through that ENI. An example of this is, maybe you have a 3-tier app, and you're starting to look at breaking it down, where you might want to have the database tier utilizing Amazon RDS, and perhaps the front end and the logic sitting inside VMware Cloud on AWS. Okay, all of that's possible. So getting started. So you'll access the VMware Cloud and AWS console, by utilizing your myvmware.com credentials. From there, you can set up what we call an organization, and you can control your identity and access management. To deploy a new SDDC, you'll basically just give it an SDDC name. You specify an AWS account that you want to link your VMC environment to. We do require a management network CIDR range, and this CIDR range should ideally not overlap with anything that you have currently on-prem or currently inside native AWS. And this is the IP range or the CIDR range that we will use to allocate IP addresses to things like our ESXi hosts, vCenter, NSX, and all of the controllers. For a production environment, you'll need a minimum of 3 hosts, but once again, we can scale that up to 16 hosts per cluster. And you'll also need to specify which AWS region, example, Oregon, Virginia, London, Sydney, you wish to deploy your SDDC to. As far as connecting to an AWS account is concerned, we basically run a CloudFormation template, and this automates that process. And this links your VMC SDDC to your native AWS account. It creates basically an IAM cross-account rule with a managed policy that's attached to it. And we use this to make API calls into the native AWS account. This cross-account rule, it's got limited access to your AWS accounts, and you can see inside IAM which permissions it has. And then depending on the permissions, some of the API calls that VMware makes can modify things like the routing table. We can attach interfaces and a few things more. But with VMware Cloud and AWS, you'll assume a rule to resolve this this cross account connection. When you access VMware Cloud and AWS through the console, you can add or remove ESXi hosts to your SDDC. You have the option for a console user in role management to configure that. You have full access to the firewall configuration. So inside the compute gateway, you can allow whatever IP addresses and whatever ports required for the application. You can request new elastic IPs, and you can use that in conjunction with NAT to allow external access to your workloads. We can establish policy-based or route-based VPNs from on-prem into VMC. We can utilize hybrid links mode in order to get that single pane of glass view of your on-prem workloads as well as your VMC workloads. We've got things like logical networking. So if you wish to create new networks inside VMC, you've got full access to doing that. Things like virtual machine administration as well. Should you wish to add more CPU or add more memory resources to some of your workloads. And then finally, all of the VM storage profiles as well. So, specifying what level of redundancy you want to apply from a storage perspective to the workloads that are running inside VMC. So a key thing to remember with VMware Cloud and AWS is that while it does utilize AWS VPC, it also has what we call a network overlay, and this is what we use NSX for. So you're going to have to can have access to, things like the management network and other networks that potentially your workloads result on. We have the all of the management components sit beside, the management gateway, and we can allow access to things like vCenter over specific ports. But then all of your workloads will traditionally run behind the compute gateway. And this is where, once again, you can allow or block access to workloads based on IP addresses or based on ports. When considering the customer's AWS account connectivity, remember that with VMware Cloud and AWS, the SDDC that we deploy as part of the process has its own VPC, and this is a VPC that is managed by VMware, and you've also got the VPC that's managed by yourselves, by the customer. As we've talked about, we assume a cross-account role inside the customer-owned account, and during what we call the onboarding process, where we're spinning up the SDDC and getting you on board into the service, as part of that process, you'll select a subnet that you wish to link the VMware Cloud VPC to your own VPC. A route table is then updated, and this is what allows us to send traffic across to the native VPC, or if the customer or yourself have workloads residing in the native AWS VPC, it's what allows traffic to connect back to workloads running inside the VMware Cloud on AWS. And we use the ANI that connects the two environments together in order to send that traffic. In the compute gateway, if the host was to fail that it was that workload was running on, then it's automatically moved over to a new host, and then as part of that process, we update the routing table to point to that ANI. So with hybrid connectivity, you've got several options. Okay, so for example, if you're going from your customer's on-premise data center to your AWS account, you can set up an IPsec VPN, and you can also utilize Direct Connect for that. If you're going between your on-premise data center and your VMware Cloud SDDC, you have the option to leverage once again either an IPsec VPN. We can leverage what we call a layer 2 VPN for stretching the network from on-prem into VMware Cloud. Or once again, we can also utilize a direct connect. And then between the customer's AWS account and the VMware Cloud SDDC, that's where we utilize the ENIs to send traffic directly between the two environments. So with on-premises connectivity, you have two gateways. We've talked about the compute gateway and the management gateway. The compute gateway and the management gateway are where the networks behind the gateway are overlay networks. So these networks are provided by NSX, and they're not part of the VPC CIDR ranges or the VPC blocks that are allocated. So I guess, for example, if you're using a private virtual interface, AWS propagates a VPC block to your on-premise environment and not the overlay networks. Then to reach the compute or the management logical networks, customers have to use either a VPN connection or a public VIF with VPN connection. With Direct Connect, you utilize a private VIF, and you can reach things like the VM kernel network, and this is what helps utilize things such as vMotion, and then we can do things like layer 2 as well. So direct access to native AWS services, this offers high performance, low latency connectivity. Through the utilization of VNIs applied to your VMware Cloud and AWS environments, you can leverage VPC endpoints. So, for example, with Amazon S3, if you want to have your VMs access EC2 instances, you can do that. It's like having the best of both worlds, where you can mix and match the services that effectively best fits your needs. The hybrid cloud extension, this allows for bulk load migrations. We're backwards compatible up to vSphere 5.0, and we support all the way up to the current version, which is 6.7. As part of the hybrid clouds extension, we also have a WAN optimizer built in. So as we're migrating workloads from on-prem into VMC, that traffic's actually optimized. We can do things like bi-directional migration. So once I migrate my workloads into VMC, if I have a requirement to bring them back to on-prem, that's fully supported and comes as part of the solution. We do require a minimum of 100 megabits network connectivity in order to support the migrating of workloads. The vSphere distributed switch needs to be in place as well for vMotion workloads, and we can either do this across an internet connection or via direct connect. We've also got what we call a built-in scheduler. So if you are doing bulk migrations, you have the ability to actually initiate the failover at a particular time. So an example might be you start the migration of a bulk of workloads on Monday morning, but you don't actually want the failover to occur until maybe Friday night at 11 o'clock when the least amount of services are going to be using it. And we can schedule all of that in. So we found a consistent set of use cases that resonate across the board, and the four main use cases that we see customers adopting VMware Cloud and AWS for are typical things like cloud migration, data center extension, disaster recovery, and also things like next generation apps. With things like cloud migrations, customers can they can accelerate their adoption of cloud services without having to effectively look at refactoring the application or rebuilding it fresh inside native AWS. And this is the ideal use cases for customers who have app specific migrations. They have a specific application that they want to migrate into public cloud due to potentially business requirements. Data center evacuations is a one I tend to see a lot of. So this is customers who potentially have a lot of separate dispersed data centers, maybe due to an acquisition, that they are looking to potentially free up those resources or save money by consolidating those data centers down into maybe one on-prem data center, and then also one that sits inside VMC. And also infrastructure refreshes. Okay, so infrastructure that's coming end of life, customers are adopting VMC in order to migrate workloads without having to upgrade that hardware or purchase new hardware, and then move those workloads freely into VMware Cloud and AWS. We've also got things like data center extension. Yeah, so customers can extend their existing data center into VMC. Which allows for things like migrating workloads in and out without having to re-IP workloads. Some customers are looking at expanding their footprint, so maybe they have a requirement to provision resources in a new region or in a new country, where certain data sovereignty rules are applied. The customer can deploy an SDDC inside that country if there's a region available, and extend their environment into that region. We have some customers who maybe don't want to provision any net new capacity. Okay, so it's been mandated from the C-levels that we need to stop buying hardware and start consuming more cloud services. And we also see customers who have seasonal demand requirements. So maybe around certain times of the year, their infrastructure needs to scale out in order to support a particular business function. But then, after that event has occurred, those additional resources are no longer required. We've also got things like disaster recovery. So disaster recovery, which is delivered as a service by VMware, allows us to protect our on-prem workloads and failover and orchestrate that failover into VMware Cloud on AWS. but more importantly, also automate the fail back. Okay, so reverse the replication and replicate the VMs back and fail them back to on-prem once that potential disaster has passed or hasn't impacted us. We see customers using it to implement things like a new DR solution, or maybe even complement an existing DR solution that they already have, and potentially look at saving costs as to not having to fully utilize the DR data center. And one that we're also starting to see more of now as well is things like next generation apps. Okay, so we're starting to see development of brand new applications using things like containers, using native AWS services, and some customers are using VMC as a means of getting to that point. So they move their applications into VMC with the premise knowing that in the next 1, 3, 5 years they'll ultimately start looking at refactoring those applications into native AWS. And it's a nice way to rethink that your application modernization strategy, and start addressing some of the new use cases like things like IoT or mobile perhaps. So let's talk about the value that we bring with VMware Cloud and AWS. We effectively allow you to accelerate innovation, respond faster to change, and even optimize costs throughout your entire infrastructure. So with accelerate innovation, you've got the flexibility to rethink the applications effectively in a whole new light. So perhaps you want to use functions as a service with things like Lambda or massively scalable database like Redshift, all along with your existing applications that run on top of VMware. By having this infrastructure co-deployed with these native AWS services, we make it very simple to think about architecture in brand new ways. So instead of having to re-architect a whole application from the ground up, you can choose to effectively modernize as you see fit. And this also gives you new ways to think about things like capacity. Okay, so as most applications deployed on premise are designed on an annual basis and are not built for peak workloads that they have to handle, but VMware Cloud and AWS, you can scale up or scale down the required capacity according to the needs of the application. And when it comes to things like responding faster to change, so things like post-merger and acquisitions, so customers, they want to get these dispersed systems integrated as quickly as possible. Maybe as part of the merger or acquisition, the company being acquired or merging has data centers that you are looking to consolidate in order to effectively save costs. With VMC, we can obviously spin up data centers. We can consolidate multiple data centers into single data centers managed and supported by VMware. And it's fully interoperable with your existing scripts that you run now. So from a support perspective, if you have PowerShell scripts or if you use things like VRA or vRealize operations, then this extends to your VMC environment as well. When it comes to things like optimizing costs, we see that most infrastructure on-prem, it's only utilized about 10% in order to deal with these massive spikes. So by optimizing and making sure that we have enough capacity provisioned on demand, we can start optimizing those spending models and move away from a CapEx model to a more OpEx model. So VMware Cloud and AWS, it is an on-demand model. You come to cloud.vmware.com and fill out the form, and that puts you in contact with our, with the relevant salespeople who are responsible for your account. We have what we call consumption-based billing. So from there, you can purchase. The process is very straightforward. We do billing based on consumption, and you can provision SDDC effectively at the click of a button, or even an API call. We offer hourly prices as well as deep discounts for reservations. So either a 1 or a 3-year reservation, and we also offer additional add-on services. So things like VMware Site Recovery, or even the potential of deploying a stretch cluster across multiple availability zones. When it comes to payments, there's obviously various methods in which you can pay for this service. We have the credit card option, so should you wish to just enter your credit card details, that's fully supported, and you can just pay on demand. Or we also offer payment via VMware SPP or HPP credits, and these can be purchased from VMware. And lastly, we've also introduced the ability to support purchase orders as well. So the total cost of ownership is a financial estimate intended to help customers determine the direct and indirect costs of a product or system. The TCO chart that we're showing there compares the cost of running applications inside VMware Cloud and AWS compared into traditional on-prem data center, and then also in native public cloud. So the blue line in the chart shows the dollar cost per VM per hour with the VMware Cloud and AWS service. VMware software delivers the benefits of oversubscription, so we can oversubscribe those hosts. And the reason that you can oversubscribe is because on average the various VMs are not using all of their provisioned CPU capacity at all times. Once again, a workload might run use more CPU memory during the hours of 9 to 5, but then during the hours of 5 to 9 through the evening, it might just be running a bare minimum amount of resources. The more VMs the customer can pack onto hosts, or the more better consolidation ratio you get, the lower the cost is. And first, VMware Cloud and AWS solution is compared with an average traditional, 3-tier on-premise environment. So, naturally there'll be a range for the cost depending on factors such as things like hardware, labor efficiency, and so on for the on-premise data center. The green line represents the average numbers that we see across the customer base. So in general, VMware Cloud and AWS solution is, it's a very attractive versus, your traditional on-premise environment from a TCO perspective. Second, the orange line shows the cost of a comparable public native instance, and customers typically purchase allocate resources of compute and storage, and generally you can't overcommit these resources. And this tends to be why the orange lines is a bit flat. So hopefully overall, VMware Cloud and AWS solution provides greater economies and technical benefits over other alternative solutions, and makes tremendous sense to maintain compatibility with your existing on-prem virtualized infrastructure by going with VMware Cloud and AWS for your public and hybrid cloud needs. So to get more detail, here's the standard pricing list. This pricing is also available on cloud.vmware.com. The offering is sold on a per host basis. So when you provision your SDDC, you choose how many hosts you want to provision in that cluster, and those hosts are billed at an hourly rate. These charges are aggregated at the end of the month, and you receive a bill from VMware for the number of services that you've used, with an additional incremental charge for things like elastic IP addresses and network bandwidth. So when you see that the charge is $8.37 per hour, it's actually quite compelling. And if you're choosing to go into longer-term relationships with VMware and purchase either a 1-year reserved instance or a 3-year reserved instance, we can offer quite heavy discounts. So if you're looking at a large-scale project, say a data center evacuation, and buy into 3-year reserved instance, you'll find the discount is in the range of 50% over the list price. And then finally, we have we've got several great resources available. You can check out the cloud.vmware.com/VMC-AWS website. On there, it shows you information about the service. Our roadmap is public, so you can see what we're currently working on. There's FAQs, and there's a lot more information on pricing and a whole bunch of learning resources. Also, if you're interested to learn more about VMware Cloud and AWS Outposts, check out the website on Outposts and sign up to get some of the latest updates that are available there. Feel free to follow us on Twitter, which is at VMware Cloud AWS. There's a lot of information gets released there about upcoming blogs and webinars. If you want to get hands-on experience with the service, our hands-on labs are an absolute brilliant resource in order to get a look and feel and see how VMware Cloud and AWS actually works. And then also, if you're into reading blogs, we have cloud.vmware.com/community, where you get an aggregated view of all of the VMware Cloud on AWS blogs that customers are writing about. And in terms of TCO, we've got pricing calculators available for you to start measuring the amount of spend that you're doing on-prem and do the conversion and calculations and see how that potentially could be applied to VMware Cloud on AWS. So be sure to register for the next webinar, which is going to focus on a bit more of a deep dive into VMware Cloud and AWS. And thank you very much for your participation in this. We're more than happy to answer any more questions that you've got. Please feel free to enter them into the Q&A, and myself and my colleague will ensure that we get all of those questions answered. So once again, thank you very much for your time, everybody, and have a great day. Thank you.